सो बेसिकली आज मैंने एक इंटरव्यू दिया एंड उस बंदे ने मेरे से पूछा कि अ, दिखाता हूँ मैं। उस बंदे ने से पूछा कि ये मेरे पास एक ग्राफ है एंड मुझे कंपोनेंट्स बेसिकली उसको बताने हैं कितने इसमें कंपोनेंट्स है। तो ही आस्क्ड मी दिस क्वेश्चन, कितने कंपोनेंट्स कितने कंपोनेंट्स है मेरे ग्राफ के अंदर। एंड दिस इज द ग्राफ काइंड दिस इज द काइंड ऑफ ग्राफ ही गिवन मी 1 2 3 4। दिस इज 1 2 3 4। सो उसने ये दिया कि 1 2 3 एंड 4 ये सब जुड़े हुए एक दूसरे से, ये सब नोड से जुड़े हुए एंड अनदर नोड 5 एंड 6। सो दीज आर डिफरेंट नोड्स। तो ये बेसिकली मेरा एक ग्राफ है, ये इसने मेरे को दिया। उसने पूछा कि हाउ मेनी कंपोनेंट्स इज देयर। तो बेसिकली यहाँ 2 कंपोनेंट्स तो है इसमें, तो उसने पूछा सॉल्व करो उसको। तो मैंने बोला ओके। तो आई नो कि कंपोनेंट बेस्ड क्वेश्चन है एंड क्या होगा यहाँ पर। बेसिकली आई यूज दिस जॉइंट सेट दिस जॉइंट सेट दिस जॉइंट सेट एंड दिस जॉइंट को वी कैन ऑल्सो कॉल्ड यूनियन फाइंड। यूनियन फाइंड बेसिकली वी यूज यूनियन फाइंड। ओके, यूनियन फाइंड में भी ना मैंने जो ऑप्टिमाइज वाला वर्जन होता है जिसमें हम पाथ कंपैरिजन एंड रेट पाथ कंपैरिजन एंड वो एक वो होता है आई थिंक path compression and range base something, it's happening a range base comparison something is there. So I use this kind of approach for this question. But in interviewer mind there's a dfs dfs approach dfs approach, because this question we can solve by dfs by same way with the bfs and with the dsu, disjoint disjoint unit union disjoint union DSU, disjoint union technique. So what I did basically, so I made the graph like number of nodes 5, made the graph same graph. Then I created the adjacency list, unordered map. I use the unordered map, or I can use the vectors of vectors also, vector of vector. Like I just write the adjacency list, vector of vector, and this kind of stuff. ATJ. Oh, I forget to put the size also. It's a size of n, size of n, size of n graph, and this is my graph and graph of every graph. Give me u and v. So this is a non-directed graph, non-directed graph. So I have to put a to j and j to v. V is basically map both the end, both the create the connection basically in both the way. Okay, and then this is my answer basically, union count, how many components, and then parent and range, then trying to put the, then I write the find function to finding the parent basically. So this parent vector and u of which I want parent, basically parent of which node. So if that parent node, if that parent node is that u, basically we are asking if we are asking for parent of u, and if the parent of u is only yourself only, so return u, otherwise try to find the parent of that thing. Okay, kind of a basic recursion stuff. So need to find, I think I need to remove this thing. So it will be this one, u finding. So I write the finding thing, v parent of v, find parent. So parent तो I done. Okay, सही था ना? I think let me see. Find parent vector. Didn't send the vector parent vector, but it's okay. Parent of u. u नहीं, यहाँ v आएगा. There will be v, and there will be parent vector, and v. Try to find the parent of this one, parent of this. I'm just asking who's your parent. So parent of parent, let's find the parent of parent. So here I'm trying to find the parent of parent. So parent of u I get here, then find the parent of this one. Okay, if we able to find that, then union means we need two things, u and v, nodes, two nodes which we need to find union. So here I'm trying to use a range based thing, a range based comparison, so here I did some mistake. So it will be like whoever the, if both are equal, then v. If both are not equal, if whoever the greater value will become the parent of that thing. So v parent become u here, because u range is greater, so v parent become u, and here u is smaller and v is have a greater value, so of course v become the parent of u. And after that I got a little blank, like, because like I'm using union find after so many days. Like I didn't have much practice on this union find, but I know the concept and how to write the, but I know the how to write the code and everything. So I just used, the find thing. Like I just wrote this thing. After writing this thing, he asked me some more questions. Like he got confused, like why I'm using range here, range, and like why, what is the use of range here. Okay, so that time, because because not so much practice on this thing, so I get a little confused here. Like I know why I'm using range here, but like exact movement thing I didn't able to explain him properly. But yeah, when I try to when I try to explain him, at that time I get the like logic why I'm using it. Let's suppose we have two nodes, 1 and 2, and if this range is 2, this range is 1. Range means rank, rank based comparison. Rank means like whatever the rank is higher, I will that will be my parent. So here 2 is my greater, so 1 parent become 2, so 1's parent become 1. So in my parent vector I write for 1 node 2 is my parent, so like that. Okay, so this is why I'm using range here. This is a range here, a range vector. So u and v, and this is my graph. And then here I got little blank, like I write the union and code function. I know it's not properly, so here I didn't write the proper function, it's a void one. I'm just filling my parent parent uh, parent vector. So here, like, if, so here will be one more condition, like what if u and v are same, u and v are same. If both are same, return, return, both are same. uh, is it correct? Is it correct? If both are equal, means they both have, if both are equal, then return. If both are equal, then return. Why return? Why I need to return from here? So I here I try to fill the my range my range. So I here basically need to send the my range. So initially all have the same thing, range and my u and v and my u and v and parent thing. I need to send the parent also for the union part. Here I need to send the vector of int. It's a range, not range, it's a parent vector. Okay, and then component, then this is my answer, then union and find also, find also. Okay, find u v range and a. So after this I got a little confused. Like I know I had the find function and union function, but here I got a confused, like how can I call them? what is the main logic here? Like how can I basically how can I call them? So I call the union, and while I know like we have to call the union because we need to couple two nodes and asking the question like what is your parent, who's your parent here, and union and find. Okay, so here I get a little confused. But yeah, it was a little advantage for me because uh, he didn't ask me he didn't ask me write the full code, but he then asked me like what is your logic and why, like dry run your basically dry run your logic to me. So I start writing, so start like explaining him why we're using this thing, why using range here. And I asked him, do you know you didn't find technique? So he said he didn't know properly, but yeah, he have a little idea, but not too much as he's not actively working, no, actively learning DSA, or basically this technique. So it's okay, it's okay, no issue. So he initially asking me this adjacency metrics. So I asked him, I'm using the agency list here, not metrics. So I used agency list. Didn't I use the agency metrics? Why will I like why will I sacrifice a lot of space by using agency list? I just using this agency list here, and this is how it will go. And he asked me one more question. He asked me hash map and hash map and hash map and concurrent concurrent hash map concurrent hash map. Okay, so I know this is used for thread safety or like in thread safety environment. And hashtag is like an old Java in Java. He asked me in Java context basically. So yeah, first he asked me explain me hash map. So yeah, I know the hash map and explained everything. How hash map work internally. It use red black tree, uh, not linked list, because and before Java 8 it used linked list, but now after Java 8 they are using red black trees. Okay, so I also know about red black tree, like they are self balancing trees, and we can like I think a log of n time we can able to find some values in there. Okay, in log of n time. So this is self balancing tree, red black tree basically, and explain me buckets and everything. And he asked me at what level you will at what level you will put uh, at what level you will put that uh, log basically. Okay, so at this time I was a little confused because I didn't know much about the concurrent hash map. Like I use it few times, but not that much time, and I forget this uh, at what level it is using and everything. So I just tell him just at bucket level put the I will put the log, because like uh, when the size will increase, so the hash code will also change because of the size and resizing of the thing. It will change the thing, and whenever someone try to access the value, and it will not able to access because the hash value is changed there. But I know it's wrong. I know it's not the correct answer because I just made up that time, or maybe just understanding of me, I just made that. Okay, hash everything about hash map, but concurrent map I don't have much idea, but it's okay. It's okay. Let's how it is it. And anything else. And yeah, he asked me one more question, which is like we have a class we have a class A, class B, and class C. Class have a x and y method, B have y and z method, and C have x and z method. Okay, so he wants to he want because x is two time here, so he wants to know like x is only have single time, only one time method basically. Like here, if I want to access y here, like here if I want to access y, or no, I think for that time what he for every, for each and every uh, for each and every x and y, y, z and y, z and x and y, and these values, for each and every method there will be single single method only, not two methods, because C also have x and A also has x. So they, I think they want he want to know only one definition of that thing. So at that time I was a little confused, like how will I achieve this thing and how can I do that thing. So he told me, do you know about functional interface? Before that I told him to use inheritance. So, but he said like if x will be two time, will x will be two time, or x will be two time there, then then so I said, yeah, this kind of property, this kind of thing. Okay. So yeah, I know about the function programming. I use it. I did like multiple ways, but for this scenario, I'm not able to understand. I'm not able to get that answer. Maybe due to lack of experience. Definitely because of lack of experience, I'm not able to give the answer of this particular question. And and yeah, he asked me three, four questions, and he also asked me about my work. What did you do at like say, at Accenture? What you did? What is a significant work? And on few little bit scenarios of different kind of like little bit behavior thing, and that's it. And he wrapped the question. He also asked me time and space complexity of this thing, and also we also discuss about the DFS approach also. Okay, because for this question I know DSA will be used, but I didn't like, then when he told me that DFS we can use DFS also. So that time there is a little bit kind of ring bell ring in my mind, and then I say, yeah, we can use DFS also. But yeah, for this question, DSU is also a approach. This is approach 1, this is approach 2, this is approach 3. So yeah, we can use approach 3 also, like DSU we can use also. Okay, and let's complete this thing. Let's complete this code. So like it will be for my practice. It will be for my practice also. So let's format that thing. So find union. I think union code is not properly there. This is the right thing. If they equal, who's the greater become the parent. So you become the greater in u is greater than become parent. And I think this is also correct. Like if both are same, so whose u parent is u. So of course it become u also, go back. But then here I got confused, like how can I call this thing? So I have to check this thing. So let's try to check this thing. So DFS, so I know DFS, BFS, and this is also, but this is, they use the here they use the DFS also, but this is not an optimized approach. No, this is not a 100% optimized code. Okay, find the parent of u, find the parent of u, find the parent of u, find the parent of v. If both parent are equal, return. Otherwise, parent u become parent u become parent u v, parent u become parent v. Okay, find the parent. If not parent, find the x. If find the parent. So find the parent here. So u parent become this. So whatever the find, we try to find the with path comparison. Yeah, with path comparison. This is a path comparison code. So I think I did wrong here. So I'm returning something, but I'm not saving it somewhere. Yeah, I have to save in my parent B also, parent B also. But I did some, I have some notes on the question on the same issue. So I will check the code on parent. When two sets are merged, one leader become the parent of the other. Yeah. Follow X, find X, follow the parent chain until you reach the leader of the set X and Y. Connect the leader of the set of X and Y. Optimized way, yeah, we can use a path comparison and we union by rank and size. Yeah, rank and size, path comparison. So I know flatten the array, ensure very fast queries. Do we need DSUs? Yeah, candidate component graph, check. Okay, then DSUs also think of like managing friend circle efficiency, element and parent, when union u X and V, then D and V, D and C and D, then they become the union C and D, then union C and D, and E and F, and G and H, N and Q, A and C, A C, E C. Okay, so C D, C D, E F, G H, then E C N. Okay, A B N, A B C D, then E F, E F, then G H. We don't have G H, so D H also. So G H also. Then A C A, A C, and E C, and F, G F, G F, and G F also. Find E, find D, same set equal. Find vector. So find function is simple. So parent, if parent is parent, खुद का parent, खुद का ही खुद का लीडर है, अदरवाइज फाइंड द रिकर्जन. नहीं कोई पेरेंट नहीं तो फाइंड दैट्स पेरेंट. Okay, union means find the parent of X and find the parent of U. If both parents are saved, then return. If both parents are return, otherwise make the parent of X and Y. Find union by find. DSA find and union by rank comparison. Okay, rank comparison, use by rank comparison step. So we already know the steps. Find parent if both equal, return, otherwise return. Find parent and parent, path comparison. So find a take log and step to compline up. We don't need to go chain wise, so we do like something like that. So we're converting into this thing, path comparison, and समझ गया मैं. And pointing to leader directly, parent. If both are find function, change in code only. There here parent जो भी recursion से आएगा वो वही होगा. So parent of I. So what is the improvement? Improvement will be this one. So parent of U is equal to find parent and U. Okay. Now if I try to find the parent of this thing. Okay. This is the comparison code. Then union. So I know it's right here, but a little bit issue. We need to increase the value also. Now we have to increase the value also. If both are equal, we need to increase the value also. K and P, we need to increase the value also. Otherwise, everyone's -1. Then whose parent become whose? U parent become U parent become V. Both range are equal. Any parent will be happy. Okay. Rank. Initially, every rank is 0. -1 or 0. Initially, every rank is 0. Rank is 0. And then why do we do like that? Rank is greater, make the parent. Why we do it? Like rank, whoever the rank is greater, make the parent. Union 1 0 1 2 0 1. Okay. union 10 union with this thing. Path comparison, path node point directly to leader. Path comparison, make node point directly to the leader. Faster find, rank by size means attach smaller tree under bigger one. Attach smaller tree under small tree under one. Fold. If both find the parent of x, find the one. If both are parent equal, parent as parent y. If both parent, find the parent of x and parent of y. Right? If both parent are equal, return कर दो सेम सेट के हैं डन है. अदरवाइज रैंक चेक करो एंड लास्ट में इफ बोथ आर रैंक सेव तो पेरेंट वाई एंड पेरेंट को एक रैंक इंक्रीज कर दो. हाँ यार ये भी तो था यार, जो मैं भूल गया. इसमें क्या था कि अगर फाइंड तो मैंने करा नहीं पेरेंट कौन कौन थे उसके. ओके तो मुझे फाइंड करना है पहले टी का. to find the x u parent होगा find है ना. find को क्या चाहिए, पेरेंट चाहिए. पेरेंट एंड to make them otherwise it will be every time it will be like disaster thing. Make them find the parent of this thing. Parent, I need to make the parent parent and you now you parent and you parent and new and int y v parent क्या होगा, v parent होगा find parent and v. okay parent होगा and you parent. I got the parent and if you parent equal to v parent, इसमें रिटर्न कर दो why because they both are same parent because both have the same parent or they belongs to the same group. ओके ये मेरे से मिस्टेक होगी. मैंने फाइंड तो करा ही नहीं उनको. यूनियन करके फाइंड यूनियन करना है. पहले दो को यूनियन करना है, पेरेंट फाइंड करना है, ज्वाइन करना है. ये कर लिया एंड यहाँ मिस्टेक हो गई थी. अगर दोनों इक्वल है सही है, बट मैंने रेंज को तो इक्वल रेंज ऑफ तो रेंज और रैंक, उसको रैंक बोल देते हैं यार. रैंक यूनियन ऑफ whose will increase, so u become the parent now. So u range of u plus equal to 1 तो उसको 1 कर दो ताकि वो इंक्रीज हो जाए वैल्यू. अदरवाइज तो वो इंक्रीज होगा ही नहीं. बोथ इक्वल रैंक ऑफ y तो पेरेंट ऑफ y बन जाएगा. y पेरेंट बन जाएगा. यहाँ पे मिस्टेक है कि x का तो इसका जो रेंज है यहाँ पर जो होगा u पेरेंट होगा. जो पेरेंट होगा जो मेरा करंट जो u का जो पेरेंट होगा वो मेरे इसका पेरेंट होगा जो मैं फाइंड करूँगा यहाँ से. सेम यहाँ पर u पेरेंट नहीं होगा, यहाँ पे v होगा ना. v डाल रहा हूँ ना मैं, तो दोनों इक्वल है तो v के को डाल रहा हूँ, तो यहाँ पर v होगा आंसर. यहाँ पर क्या होगा, बोथ आर इक्वल. रेंज मेरा बड़ा है तो who is the greater, range is greater तो ठीक है. don't have to do anything here, I don't have to do here. so parent और v दोनों इक्वल है. parent u and parent v इंक्रीज कर दिया, both are same and parent of v is greater than parent of u. तो उस टाइम पे मेरे को v डालना है उस टाइम पे मेरे को. and at this time I have to v parent v is greater, so parent v smaller, so it become u, which means u parent I have to add here. It's parent of u and this parent will be parent of v parent because I find the parent of u and v, find the parent, so parent and u, so parent of v and v. If both parent are equal means they both belong to the same group, so left from there. Otherwise check the range. check the range. If they not belong to the same group, check the range. Means किस की who's my daddy? who's my daddy? Who's my daddy? Okay, then who's my daddy? Otherwise, who's my daddy? So if both are rank are equal, okay, so I'm making the V a parent, because why I'm doing this? But why I'm doing this? Parent, making a parent. Why I'm not making directly V? Because I'm doing a compression, union by rank. Union by rank कर रहा हूँ मैं. I'm doing union by rank. So union by rank means I am I am uh, I'm doing I'm
Okay, मेरा why camera is not working? Right.
working, guys. Camera is not working. Okay, now it's working. Okay, now it's working. So that become my parent. And same thing here. So I think union find I already write the here. So this one is like union by rank, and this is like path compression. Path compression means I'm making same parent to that parent, pointing directly to that parent, pointing directly to that thing. And here add the adjacency list of n size, make the thing list parent and this. How many component is my answer? Range I'm sending. And now how will I call them? This is my main concern here. Okay, so let me check my notes. X, so x parent को x find मैंने कर दिया. Parent return same set के होते हैं. Whoever the rank, so x parent, u and v parent. Yeah, there is mistake also. So rank of this parent, so whose parent rank is greater? So I need to check that thing here. So rank is greater, u, if u rank of that parent, check the rank of that parent where the parent rank is greater. So we are adding that parent to that node. Okay, so here will be u parent, u parent, u parent, and u parent, and here we are using v parent only. Okay, fine. We find the parent of x and y, basically u and v. If both parent are equal, means they belong to the same set, same group. Otherwise, check their rank, parents rank, check their parents rank. Okay, both are parents same, anyone else. If both are same, so make anyone, choose any. So I choose this one, and whatever you're choosing, so range of v will be increased. Okay, this is the union find logic. But main thing is how can I make, like, how will I call them basically? And I know this is my answer, and this is the main thing. How can I call them? Initially everyone is single nodes. Everyone is single, so I will ask u to v and v to v nodes 1 to 2, nodes 2 to 3, not 3 to 4. Okay, 1 node, 2 node, 3 nodes. So here I did here. So how they call it, how they are calling it, bath. अरे यार ये सब तो ये सब तो ऐसे है. Count, so I use the BFS here. Disjoint set, find parent of x, parent of y, make the respective parent. Right, find parent, union find. Okay, so here we are doing union find function. Initialize the parent array with each size. Okay, initialize everyone. Initialize the parent array with each element at its own representative. So parent vector will be union find of size, union of 1, 2, 3, 4, union 1 and 2. Here I'm getting a little bit confused. So मैं किसको what will I call 3 union by rank. Yeah, rank wise तो I know. Rank I know. So how they're calling, they root by return true, find the recursion. Here they use recursion if not return, both parent are return, otherwise find the root. If both parent are equal, then root, otherwise find the root of that thing. And union set containing x and y. So find the parent of x and y. If both parent are equal in same set, not to union, by rank by union. So whoever the rank is greater and that thing, and at the end rank increase kar do x की. Then main thing is here. Let me, there's a 5% with ID 0, 1, 2, 3, 4 and n is 1. Disjoint union. This is my graph. So this is a graph, G1 graph. Okay, solve to I got the approach. So we are written in the same city for relationship between this. Data structures used here, array and tree, disjoint set. I know this. I know. Union find I will use. Okay, I know this will be used, and they will be used. And path comparison is this. Path comparison is this. Path comparison is this. Union rank by parent of x. Who's your parent? Who's your parent? But the parent will be the parent. And here is constructor. Initialize constructor resize and parent को make it parent of each and parent to each. I think मैंने I did the wrong here. Parent तो everyone parent is everyone parent initially. So for int I equal to 0, I smaller than n, smaller than ni plus plus. तो parent of I is equal to I. अभी सब अपने अपने parents है. So parent and parent of in, parent of I, parent smaller than parent of I, so parent of I. And this is my range. So initially everyone is 0 range. And then, so here is my main concern. How can I find this thing? How can I find this thing? Find, तो I done union set. How can I call this? This union set n size का है. This set n size rank बना दी उसने. रैंक को, अच्छा रैंक यहाँ पर है, इंटर पेरेंट रैंक कर दी, पेरेंट को साइज कर दिया, पेरेंट को इनिशियल कर दिया हर एक उससे. ओके, यहाँ कैसे करा उसने फिर? 0 is a friend of 2. How you know? Union set. 4 is a friend of 2. 3 is a friend of 1. Check if 4 is a friend of 0. Check if 4 is a friend of 0. 4 components. I'm missing some. I'm missing a very major concept or major issue here. How can I? इसको रिमूव करो, इसको रिमूव करो. Let's ask to ChatGPT. ओके, इसको पूछो भाई ChatGPT से क्वेश्चन. कोड फेंक के मारो. uh, I am missing a point, like like how can I how can I how can I call or all help or use union set union find to find number of components in number of components in my graph. Don't tell me don't tell me code, just just give me give me just give me an hint hint or where I am missing where I am missing. Good question. You're not missing syntax. You're missing the mental model of what Unified is supposed to track. Yeah, Union does not care about agency list. Okay, but Union find actually represent key missing point. Union does not care about agency list. It only care about edges. For every edges U and V, U union U and V. This means U and V are the same connected component. That's it. You don't need DFA, you don't need DFA, you don't need to traverse neighbors, you just process each edge one by one. Uh, when do components change? Initially, every node its own component. So number of component will be number of component will be number of nodes. हाँ ठीक है. Initially components number of. Okay. चैट जीपीटी को चल गया भाई अपना सीरी को ऑन हो गया. And each time you process an edge U and V. If find U and V, you merge two components. If parent of U and V is not equal, if parent of U and V are not, you merge two components. Component count decrease by 1. If U and V find V, they already connected. Component count does not change. This is a single most important idea you are missing. Yeah, I do component change. This is what I'm missing. Where you think is going wrong, you are doing building a list, thinking about graph traversal, but union set wants this instead. For each edge, try find union. If find happen, component find. If union happen, components minus minus. So ask yourself, at what exact moment do two component become one when their parent are not equal? Yeah, answer is when you are not find. So what answer should actually means? Right answer 0, but think what is answer counting? Edge no, edge no. Answer should number component. So ask yourself what is the starting value of the answer by union before union, which is n size. Answer the answer unlocks everything. Sanity check with your graph mentality edges 1, 2, 2, 3, 3, 4, 5, 6. So initially all are separates. Union 1, 2, 2, 3, 3, 4, 5, 6. So 1, 2 component decrease. All component decrease. How many times did I actually merge two components? 1 2 3 1 2 4 times. 1 2 3 1 2 3 1 times you actually merge. So 1 2 merge, 3 merge, 4 1 2 3 and 4 times I merged. The count tells you final component. If you answer these questions, you will get it. What value should component start with? So I think start component is, so answer will start with my n value, number of nodes. So I have n number of nodes. I have n number of nodes. I have n numbers of nodes. N number of nodes. n number of nodes. n number of nodes तो मेरे पास हो गए. उसके बाद में मेरे को यहाँ पे यूनियन फाइंड करना है बस. For auto g graph. Okay, so what basically I need to do here, so I need to call union. I need to call union of, so int u will be my g0 and int v equal to my g1. Okay, here I will call v and u and v, and here I have to call the parent range, and then parent range and parent range and parent, and here also parent. Okay, this is what I need to ask every time. But when I will decrease the value, when will I decrease the value? This is I need to do, and this is I need to do here. After doing this thing, I have to go through my parent list. I guess the answer lie there. Auto s auto it g graph, my graph if parent of u is not equal to parent of v, if they are not equal, then do the union thing, then merge them, then union, and then add them. Basically do this thing, find them, find if they are not, if parents are not equal, do this. If parents are already equal, you don't have to keep both parents decreasing it or compare separating, then union with these two unions, range base u and v components. क्या मैं गलत कर रहा हूँ अभी भी? मैंने ग्राफ तो मैं बना लिया, तो u and v जुड़े हुए अभी, तो u and v का पेरेंट कौन है अभी? एजेंसी लिस्ट तो बताएगी मेरे को कि कौन किससे कनेक्टेड है अभी, क्या मैं गलत कर रहा हूँ? एजेंसी लिस्ट तो बताएगी मेरे को कि कौन किससे जुड़ा हुआ है, आसपास कौन नेबर्स है उसके। और यहाँ पे मैंने अपना पेरेंट बना दिया, रेंज मैंने बना ली अपनी, और मैंने अपना कॉल, मैं still I'm missing something here, still I'm missing the main thing here. क्या मैं मिस कर रहा हूँ यार? यूनियन तो केयर नहीं कर रहे, केयर does not, since if केयर edges you edge if, so you don't doing PFD, every node its own component, so the number of components equal to number of nodes initially. हाँ इतने components, so each time you process h e and u and v, if find u and v, you merge two components. If their parents are not, find means parent ही तो है, if their parents are not, if you merge two components, if their parents are not equal, you merge them and decrease component by them. And then if they're equal, you're already connected, count range to single method, you are just doing traversal, but should wants this for each edge. Try union. If union happen component minus, at what exactly moment do you component become one? At what exact moment do two components become one? When they and their path is and you union them at answer should actually means 0 right now. Simple, but think what is answer counting. Edge is no, not new answer should represent number of counted components. Ask yourself what is starting value of answer before any units. Initially, we have number of connected components, so single component and size unlock everything. So this time separate union 1, 2, 2, 3, 4, 3, 4, and 5, 6. So component will decrease. 1, 2, 5, 4, 5, 5, 1, 2 times it is actually merge. You want to merge. Let's count it. We'll find components. यही मैं main this is what I'm missing in the interview. This is what I'm missing in interview. Like whose parent is whose parent. I know you didn't find code. You didn't find. लिस्ट ने क्रिएट कर लिया तो अगर GNC UNV parent of UN parent V not equal right now all are their parents. Let's try to debug. Just try to say this thing. So currently we have 1, 2, and 3, and 4, 5, and 6. Okay, so 1 merge, then 2 merge, 3 merge, 4 merge. 4, 6 minus 4 answer side तो आया. If union happening, then my answer minus. If their parents are not equal means they belong to different groups, so I need to merge them. So how exactly it will work? So parent 0, parent 1, parent 2, parent 3. Okay. Currently I have a parent. I have my parent. So 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6. Okay. Try to merge them. So right now 1 and 2 parents are different, so you merge them. So your answer was 6. Now become 5. You merge them. So how it will look? It will look 1. It belongs to 2 now. Okay. Then 3 and 4. You do 2 and 3. 2, 3 and 3, and the parent become 1. Then become 1 and 2 and 3. So 2 and 3 means 2 and 3. 2 and 3. Okay. 2 and 3. So you merge 1, 2, 2, 3, 3, 4, and 5, 6. Then you do 2, 3, then you do 2, 3. 2, 3 means 2, 3 and the computer not equal. So you again merge them. So you 4, and now it become 3. Become 3. Okay. Then after 4, now you're at 4. Now you're at 4, 4, 4 here. So 4, 3 and 4, 3 and 4. So yeah, this become also 1. So 3 and 4 are they are not equal. Basically 1 and 4 equal to 1 and 4 belongs to some other. 1 belongs to here and 4 is it belongs to 4. So I need to make them. So again 4 comes to here. 4 become here. So this structure looks something like that now. So yeah, its parent become 1. Because here the 1 rank is also increasing. So 1 rank is initially 1 but become 2, and 2 rank also increases. So 2 rank, 3 rank. Okay. 4 rank, 5 and 6. So 5 and 6. So here I get to know. So I'm at here 1 and 5. So what will happen? So 1 and 5. So what will happen? 1 and 5. So they both are equal. They both are different. And rank rank of this thing will become currently is to here 4, so here it become 4. They all single, so I cannot add it to here, cannot do that thing because it's a separate component. It's a separate component. It's a separate component. So what will happening here? 4 and 5, you try to merge 4 and 5 and dry run this thing. You dry run this thing to understand. So U and V, their parent are not equal, of course. You union them, union the answer become this, answer become this, and let me try to run this thing. See what answer component vector here. There is a mistake 22. Mistake is here. Segmentation fault. Wow. ADJ of size n of size n. ADJ of signs of n, which is 5, 1, 2, 6 over y. This will be 6. Number of components, I have a 6. I have 6 nodes. I don't have 6. I have 6 nodes. So 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. So I have 6 nodes. So ATG of 6. It will be 6 length map, and 1 belongs to 2, 2 belongs to 1, 3 belongs to 1, 3 belongs to 1, 3 belongs to 4, 4 belongs to 3, and 5 belongs to 6, and 6 belongs to 5. This is how it will be look. So list graph and ATG list. It is a list of this thing. So U and V key. So adjacency of AG of U, put this thing at one map and a vector, so that put V and V to U map basically V to U and U to V, U to V, 3 pointer segmentation, a board and middle pointer. Okay, एक pointer ऐड हो गया भाई, U to V, V to U, and parent हो गया मेरा n size का, parent is my n size parent, and 0 parent of n size, 0 to n, put the value, start from 1, start from 1 parent is 1, so 0 parent is 0, that's fine, or you can say 1 parent is 1 and equal to 9, okay, and minus 1. So 0 parent is 1, 1 parent is 0 parent is 1, and 1 parent is, we have to map it like that, otherwise it will be wrong. So we need to map it like that. Range, initially our range is 0, and parent will be for 0 parent 1, 1 and 6. So 5 is 6, 5 is 6, 1 to 6, 1 to 6, 1 2 3 4 5 6, and 6 minus 1 5. So parent of 5 is 6. Okay, this is the, but range is also okay. Range and 0. Graph U and parent is parent of V equal to, if not equal, you make the union Like the union range u and v vector parent. Okay. Code is little lengthy but not. सेगमेंटेशन फॉल्ट आएगा दोबारा से सबमिशन क्यों सेगमेंटेशन एरर भाई कहाँ गलती है इसमें पेरेंट 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 ऑफ यू यू पेरेंट का यू यू ही पेरेंट ऑफ यू इज ऑलरेडी यू मीन्स पेरेंट ऑफ जीरो पेरेंट ऑफ बी parent of let's don't do this thing here don't do this thing here zero say 0 to so do here so n size n size n size so n minus 1 minus 1 okay minus 1 so 0 और minus 1 डाल दो ताकि वो गड़बड़ी ना हो बाद में ज़ीरो साइज ज़ीरो होना चाहिए ऐसे करके यार ये कहाँ से दिक्कत आ रही है इसमें This line is wrong in idea, not syntax. Primitive union find only find tells you which component belongs to. Because path comparison change parent laziness are nodes directly find may not be root. Root. Are you correct? Mental model. Are you and we in different component? The question is always answered by find. This line single biggest mistake cause wrong answer. Okay, find करना है मेरे को. Parent if both parent are not equal. Both parent are not equal. Find u and v. Find u and v. The find now my find is there. Find means I'm trying to find the parent if parents are not if they're find u and v not equal and something segmentation find u and v try typo it's just a function it's a function it's basically a function it's not a function it's a function index mismatching slide work you graph use this parent size is 6 parent index is 6 if you correctly indexing in the same vectors but forget to do this here so you're calling find 6 out of bound union wrong nodes correction find ultimately in the same index say a parent range wrong weakness should I attach you parent range root parent u and parent v on touch parent अच्छा हाँ so don't touch you never touch parent only touch parents of parent I made the mistake here asking you parent of you and you should I ask ओ यार कंफ्यूजन की वजह से बहुत सारी मिस्टेक्स हो रही है कॉन्सेप्ट एक बार अच्छे से करना पड़ेगा दोबारा से nodes must live in the same index do it here Should I be attached to your union point? You always attach to the root. Rank is equal to the root. Never touch parent. Only touch parent, of course. This won't always break correctness, but it breaks the DSA guarantees. This part is conceptually right. Every success union reduce component by one, and their thinking is another correct. Sure, fine. So here, basically, parent of change the parent. I only need to play with the parent here. I need to only need to play with the parent here. Parent. Only U and V. I will find the parent of U and V. If their parent is themselves, though, this will you use. Okay, we should run. So -1. So G -1 -1. They need a parent also. They need a parent also. So need to parent also. If the parent are not equal, then try to find a merge. 2. Oh my god, आंसर सही आ गया भाई. अब जाके आंसर है. If their parent are not equal, find the parent. If their parents are not equal, hence they merge them. If the parents are not equal, merge them. Number of disjoint sets. But forward to do it here. So we're calling find checks, which is out of bound. Let's see the thing. Yes, this doesn't show the click happened. So that is not conceptually correct, but answer for this will be right. Finalize sanity pass thinking or so correct component check. So you now do if parent of this is not true. Just correct and only safe check. No more false assumption about parent. So if if parent of u is not equal to parent of v, parent of u is not equal to parent of v, so do this. This is the correct and only safe check. If where are you parent of v is not equal to parent of v, then do the union part. Then you that do the same, like merge them. If merge happening means if merge happening like there's less components is there, so less components will be there. So create model will be inside union. So you only attaching roots to roots. Rank is updated on the root. Union, you are attaching parent of that to parent of v, parent of v to parent of u. You are only attaching roots to roots, roots to roots. Rank is updated on the root. Rank is updated on the root. Union bank row is now valid. You fixed this. Parent array and graph now live in the same index spaces. Parent array and graph now live in the same index space. This you implement only when the range merge actually happen. Try run. This small thing not wrong, just unnecessary. This part you never use agency at does not need agency list. Edge alone are enough. The bug just extra. You are correct the parent. You have crossed the harder DSA barrier. Parent array tells me the component. Only find tells me the component. Find tells me the component. Only people get stuck here for fix you don't. But it correct DSA will maintain counting right away. This is faster. ओके भाई ये करेक्ट वर्जन है DSA का. तो ये कोड होना चाहिए था मेरा उस टाइम पे. एजेंसी मैट्रिक्स मेरे को नहीं चाहिए, तो मैं इसको रिमूव कर सकता हूँ यहाँ से. डोंट नीड द एजेंसी लिस्ट. range based component. At the end, how it will look. So how it will how, how all nodes look after the DSU completion. So we expect two components, component 0 to 3, 4, 5. Step by step evolution. So initially, so every parent has a origin parent, and rank is 0. Yeah. So union find will 0, 1. So union by rank. So same rank 0, attach 0 to 1. So become 0 to 1 rank. So increase. So attach 0 under 1. Okay. So attach 0 under 1. So rank of 1 will increase. Yeah. This will look something like that. So union 1 and 2. Go again there. Union root 1 and 2. Root of 1 is 1 and root of 2 is 2. So root of 0 1. Root of 1 is 1. So it 1 have single root and 1. Parent of 0 is now 1 and 1 is only parent of itself. Okay. So rank of 2 is 2. So rank root of 2, basically parent of 2, if it's 2 only rank of 1 greater than 2. So 2 attached to 1. So 1 become 2. So it become 1 and rank of it become 2. Okay. Rank increase to 0. Find 1 and 2. So become 1 and 2 under 3 to 1. 3 under 1. Attach 3. 1 have a higher greater value. So 3 will attach to it. So 3 will attach to it. So it becomes, so all are attached to it. So this will look something like that. Union 4 and 5. So union 4 and 5. Same rank. Attach 4 to 5. So they have a same rank. Union 4 and 5. Union 4 and 5. So they both have the same rank. So same rank means attach them. So they both have the same rank. So attach them. Why rank is not increased here? Why rank is not increased here? If both rank are equal, then increase. If not, if both are not equal, rank, we don't need to increase its length. We don't need to increase its length. Okay. Only when if rank is only when if rank here rank is increased, same rank. If both have same rank, only then attach. Only same rank time pe I will attach now. Only if who's your daddy, if same rank are there, only then I am attaching. Otherwise, I'm making the parent of that thing. Union 1, 2, 1, 1, 2, 3. Union of this, union 4 or 5. Find DSU important parent. So this is the last thing. Component 1 root 1 component 1 root 1 0 1 2 3 root 2 4 and 5. K inside every input, and all nodes in a component do not need to point directly to the root. Find root, same root. So all nodes in a component do not need to point directly to the root. They only need find node, same root. After full path comparison, it should become 1155 parent. So parent is this. So even flatter if you call find on every node. Both are correct. So nodes, all nodes in a component, all nodes in a component do not need to directly point to the root. They only need find of that root, same root, equal to same root. After full path compression, it would become 11155. So flatter even flatter if you call find on every node. Both are correct. One line DSA. If you one component and the root represent a component. Node, how to take cycles, how to take cycle directions we can do, yeah. Direction, what happen after calling find on every node. Calling find. why this is almost known. So calling find on every node applies full path compression, making every node pointer to its component root. DSA tree becomes completely flatter. So for the previous example, DSA looks like this. This is already shallow, but not guaranteed is general. So calling find on every node, you find 0, 1, 2, 3. What path compression does? Find X runs. It recursively find the root, then rewires every node to the path to pointer to the root, then rewires every node to the parent. Or the full compression of parent becomes this star shaped trees. Component check instant component. Well, DSA become almost constant time formation. Alpha is the like Karman does not automatically compress path for all nodes. Path compression happens only when you call find. So some nodes may still have multi-level parents until they call queried by find all in find data structure. Calling find a node, each component one root. All nodes in the component direct child to root. DSA become a set of letter stars. Flat harmonics. The key why DSU still works even if trees aren't flat. For every two nodes, UNV find UNV, but nothing else is required. If their parents are not equal, merge them. 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 Tree shape does not affect correctness. The structure is perfectly valid. Path compression delay. Nodes flatten only when touched. Frequently accessed nodes become flatter very quickly. If a node is rarely queried, doesn't matter if it is deep and frequently queries path compression flattens. So DSA automatically to use usage patterns, median by rank, path comparison, total number of operation in nodes, and where n is not linear, constant power, constant time. मुझे पता है static graph one command ds is o into e ds is like oe and ov dynamic graphs and online queries. So e every edge you're calling and vector तो नहीं करते, every edge we are calling it. We are doing simpler. Graph is changing, edge edit, send it to a graph is changing, DSA when any connectivity queries, or even DSA destroy, BF and DFS, cycle detection. DSA is ideal. Connectivity check, log on dynamic edges, finding, solution, medium is ability, traversal, BF is about exploration, not relationship. Tool. DSA is about relationship. Relationship बताता है और not traversal is about exploration. We explore the use the right tool. Through DSA, not connected. Traps. Parent is not equal to component. Component text cycle. For logic, background UAV, if we find U and U style exist, else in U and V. Directed cycles. Near zero, CSDS is zero, incorrect. Alpha and trap. Both are valid. काफ़ी चीज़ें भाई, बस ख़त्म DSU. इसको मैं इस कोड को मैं पुश कर देता हूँ अपने से, तो इसको मैं पुश मार देता हूँ अपने गिटअप पे.